qualify for the finals in the racing event, a race car must achieve an average speed of 250 kilometers per hour.
Stop. So, 250 kilometers per hour is the speed.
Yeah.
That's what I'm supposed to write, Claire?
No.
Well, that's what you said, is it not?
Yes.
Okay, so what am I supposed to write?
250 kilometers per hour equals S for speed.
Sure, we'll use an S for speed.
On the track, total length of 1,600 meters.
Stop. D for distance equals 1,600 meters.
If a particular car covers the first half of the track at an average speed of 230 kilometers per hour,
Stop. 230 kilometers per hour equals
I'll help you out. Right?
um,
But there's a problem,
yeah.
right? Okay, so talk to me, what's your problem? What are you confused about?
Well, it's the same variable as the first speed, but it needs to represent a different thing.
So what do we generally do when we have the same variable representing two different things? Max?
Yeah, subscript.
Add subscripts. So what do you think the subscripts should be on these two different speeds?
1 and 2.
1 and 2. I'm going to stop you for a minute because if you read the problem, it's actually not 1 and 2, aren't you?
Speed total distance.
Okay, this, the 250 kilometers per hour, as stated in the problem, is the total speed for the entire track. And this distance is 1,600 meters for the total track. And then this speed, the 230 kilometers per hour, is for the first part. Dave?
what minimum average speed must they have in the second
Hold up,
half?
let's back up. We missed a piece of information. Just start over again, and Claire, pick it up. We missed a piece of information.
To qualify for the finals in a racing event, a race car must achieve an average speed of 250 kilometers per hour.
I'm going to stop for a second because this is kind of fun. We're having to read the problem again. Class, is that okay? Yeah, I got this response like, oh, we have to read it again. Yeah, you're going to have to read it again. And you might have to read it for a third time. Woe is us, okay? In order to understand it, sometimes you have to read it more than once. That's okay. So we're going to start over again just for fun, Dave.
Right. To qualify for the finals in a racing event, a race car must achieve an average speed of 250 kilometers per hour on a track with a total length of 1,600 meters. If a particular car covers the first half,
Stop. So the distance that D1 would only be 800.
I'm going to do it this way. I agree with that, but just to be clear, it's the total divided by 2 or 800 meters, right? Just to be clear.
half of the track at an average speed of 230 kilometers per hour, what minimum average speed must they have in the second half of the event to qualify?
I'm going to put equals question mark, and your job right now is what are we trying to find?
The average speed per second.
What am I going to write down?
S2.
What else? It's okay. This is one of the major obstacles in this class, is taking the words, translating it into knowns, and figuring out what to do with it. Ben?
Since D1 equals 800 meters, D2 has to equal 800 meters.
Just to make that absolutely clear, the total distance is equal to distance 1 plus distance 2. So the total, so distance 2 is equal to distance total minus distance 1. I know it's obvious, but this is how you would write it out. So distance 2 then is equal to, bless you, 1,600. Somebody count for me. It's not minus 800. Distance 2 is equal to 800 meters. Again, I know it's obvious, but if we're not, a half, it might not be quite as obvious. Is anybody counting? Because it would be kind of fun. Okay, we now understand the problem. We're solving for speed 2. I find it's helpful to have visuals, so let's put a visual up on the board. I'll put it up here. We have an entire track. We know that the speed total is 250 kilometers per hour for the whole thing. Okay? But we also know we are splitting that up into two different pieces. We have, this is the total, this is part 1, and this is part 2. So we know we have the distance for part 1, and we have the speed for part 1. And we have the distance for part 2, and we are looking for the speed for part 2. In other words, for the whole thing, we need to average 250 kilometers per hour. For the first half, we averaged 230 kilometers per hour. What do we need to average for the second half in order to have an average speed of a maximum of 250 kilometers per hour? What would you like to do next? Or, Alejandro, there.
Well, I found time for part 1.
How'd you do that?
I took 1,600 meters times 1 hour over
Okay,
200.
we're not gonna start there. We need to start with our first step. You don't wanna have to call Oscar. What is our first step? I understand that maybe right here you can see it, but the truth of the matter is that down the road, not so far, we're gonna run into issues if we start by just writing down numbers. Your shot.
Distance equals speed over time.
Distance does not equal speed over time.
Oh, sorry, speed equals distance over time.
We're gonna start with the equation. Speed equals distance over time. You can see that we have a whole bunch of speeds and a whole bunch of distances, but we do not have any times. So we are going to be solving for a bunch of different times. So let's start by solving this equation for time. Karen, how are we going to solve this equation for time? We're going to multiply both sides by time. When we do so, we get time multiplied by speed on the left is equal to distance because time cancels out on the right. Divide both sides by speed. We get speed cancels out on the left. We get the time is equal to distance divided by speed. Okay. Time equals distance divided by speed. Ash, what are we going to do with that? For example? Okay, so we can start with the total. So the time total then is going to be equal to the distance total divided by the speed total, just as an example. We have the distance total. What are our numbers here, please, Lindsay?
1,600
Divided by?
divided by 230.
Trevor.
Shouldn't the total speed be 250?
The speed for part 1 was 230. The speed total is 250. Six point four time in kilometers per hour. Meter hours per kilometer are the dimensions we're going to get on this. Does that sound good? No, doesn't sound good. Gotta fix it. Ezra.
We want to convert the 1,600 to.
You need to make sure that all your dimensions are going to play well together. We have meters and kilometers. They're not good friends. Okay. So we need to convert. So 1,600 meters, we have 1,000 meters on the bottom, 1 kilometer on the top. Meters cancel out. We have 1.6 kilometers. That being said, we can come back to and let's replace all of these. I'll just do it over here, I guess. So distance 1 then is going to be 800 meters multiplied by 1,000 meters, 1 kilometer, 0.8 kilometers, which is also equal to distance 2. So rather than having 1,600, we should have 1.6. Which means rather than having 6.4, we should have 0.1264. 0.0064. Now we need dimensions. Let's work out the dimensions. We have on the top 1.6 kilometers. On the bottom, we have 250 kilometers per hour. And we need to figure out the dimensions. In order to figure out the dimensions, we need to harken back to, I believe, middle school and a fun phrase from middle school. Who can tell me what it is? Go ahead. Flip the guy and multiply. The guy in this particular case is going to be kilometers per hour, whom we are going to flip. So we're going to have kilometers per over kilometers per hour is going to be equal to kilometers multiplied by hours over kilometers. Notice on the top, this is actually kilometers over 1, so this is actually kilometers over 1, kilometers over 1. So kilometers cancel out, and we get for our dimensions for this hours. Do not forget, I think that was a bless you, I don't know if it counts or not. Do not forget to flip the guy and multiply. So 0.0064 hours. I want to make sure we understand what this time represents. Tyler, what does it represent? See, I was close. See, I got Trevor, and then I was like, it's not, it's Taylor. It doesn't, I don't know. Taylor, sorry. That doesn't make any sense. It's my fault. Taylor. Yes, but I need more specifics. She said the total amount of time it took for the race car, but for what? Yes, I agree with that, but Alejandro?
The total amount of time it took to cover 1,600 meters, so it must be at 250 kilometers per hour.
Right. So this is the maximum amount of time we can take in order to go on this race and have an average speed of 250 kilometers per hour. Great. We've figured out the total time. What should we do next, please? Frederick?
Solve for the other speeds.
Okay, how?
And solve for the other times.
Okay, how?
So you write the equation, speed equals distance over time.
We've already done that.
Time equals distance over speed.
Time equals distance over speed, more specifically.
The time of the first one and distance of the first one and speed.
Distance for the first part is 0.8 kilometers divided by the speed for the first part, which is 230 kilometers per hour. We get time 1 is equal to 0.8 divided by 230, or
0.00347.
0.003,
47.
one more, 8.
Yeah.
Bless you. And that again is hour. Rishad, what does this time represent?
The average time it takes for to cover half the track.
This is not an average, because this is an actual event. We have used this much time, Megan.
The time it took for the race car to come the first half.
This is how much time we have used for the first half of the track. What should we do now? Arjun?
So that time total by time or time for the first.
Let's start with an equation. I agree with that, but in the long run, we need to start with the fact that we know that the total time is equal to the time for the first part plus the time for the second part, right? So our goal is to figure out the time for the second part, which is equal to the total time minus the first time. Right? Start with the fact we know if we add both times together, we get the total time. And then, do you keep squinting, Arjun?
Oh, I forgot my glass.
Okay, good thing you're in the front. Can you still read?
Yeah.
You don't need to sit here? Okay, okay. please remember your glasses because you're doing that a lot. Okay, so time 2 then is equal to 0.0064 minus 0.003478. Time 2, please. 0.0029. One more. Spencer. Specifically, what does this time represent? Close. I would say how much time we have left for the second half of the track for what? In order to attain what? Mike?
200 kilometers per hour average.
If we take more time than this, our speed is going to be less. We're not going to qualify. So this is the amount of time we need to have here. If we take any more time, we are not going to qualify. We're close. Brad, what are we doing now?
Well, we can go back to our speed equation. Let's say S2 equals D2.
Hold on. Could you give it to me in words rather than variables?
Speed, like second speed equals the second distance over the second time.
Great. We have the second distance. It is 0.8 kilometers divided by the second time. We just figured out 0.002922. Speed for the second half. Okay, let's stop for a second before we calculate this. Oftentimes, students will look at this problem and say, we averaged 230 kilometers per hour for the first half. Therefore, class, we should have to average what for the second half? 270, right? Because we did 230, it's 20 kilometers less per hour on the way for the first half. So it should be 270 for the second half. Let's see. What? Does it work out to be 270 kilometers per hour? I'm going to go with a no on that one. Yes with sig figs, okay? I do understand that with speed 2 with sig figs does work out to be 270 because if I were writing this textbook, I would try to make sure that we had 3 sig figs on this so you would identify that it does not work out to be 270 kilometers per hour. It's actually 274 kilometers per hour. And there's an important distinction here because when you're trying to figure, when you say, well, it's 270 kilometers per hour, what you're saying is that the speed total is equal to speed 1 plus the speed 2 divided by 2. Right? That's what you're doing. And this is not equal to the correct answer. And that should look familiar because we did this last time. What? Have fun.
Do you want to sign it?
Do you want me to sign it? Does it have a spot for me to sign it?
I think there might be.
All right, if there is, I will sign it. If there is not, I will not. Ladies and gentlemen, people get excited. You are about to find out if there is a spot for me to sign.
Just sign with the special initial.
Ooh, I will initial, I guess. Oh, I have to write down the time too. What time is it?
9:17.
17 we'll go with. All right, enjoy.
Thank you.
Counsel well. So, this does not give us the correct answer. Under what circumstances, Rashad, will this give us the correct answer? That's fine if you have it. That's fine. Go ahead.
Why are there 2 sig figs?
When we get there, I'll come back to that. We're in the middle of this question. I'll answer that in just a moment. So, under what circumstances would this be correct? If we could just add the 2 together and divide by 2, Spencer?
If there was 3 sig
If there were...
3 sig figs.
No, it doesn't have... It's not a sig fig question. That's okay. See, that's not fair. Crittenden?
If you're taking the average of the speeds?
Well, the average speed here actually will work out to be 250, so that's not correct, because we are actually working out to the average speed here. Susan?
Unless the velocities or the speed are the same.
No, it doesn't have to do with if the speeds are the same. That would be true. That would be a special case. Brad? No, you're not Brad. Ryan?
Do you have to account for the time that it takes to accelerate to the speed?
That would be, we're talking about in an ideal world. I agree. We can't get there in this class today.
Okay.
But yes, that's unfortunately something we do have to ignore. So let's review what the question is, okay? Because we're not quite there. That's okay. We get 270 kilometers per hour if we simply add one plus the other to divide by 2 to get the average speed. But that's not correct. And under what circumstances would that be correct?
If you're traveling the same speed at the same amount of time.
For the same amount of time. It only works if the time 1 is equal to time 2. Was that true here? No, so it's not true. So do you think that really I'm going to really ever give you an instance where this is true? Because is that useful? Milan, this doesn't really test your brain much. This is much better.